Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we continue looking at object declarations, and we're going to look at a second usage of the object declarations. In this case we're going to make companion objects. So in some ways, as the name implies, a companion object goes along with something else. In this case the something else is a class. So when you make a companion object, you have a class that has a given name, and you make another object that has the exact same name, and you have to put the companion object in the same file as the class itself. So to demonstrate this, we're going to go and play with the vector class that we wrote previously. So in this class we have this vect3. It stores an x, y, and a z as variable doubles, at least as it's written here. And I have some code down here that would be run when this was a script. Now, one thing that's worth pointing out on this is if I try to run Scala C, so the compiler, on our vector, it doesn't work. Okay? And the problem here is that this code is not nested inside of anything else. And while in scripts it was perfectly valid to have top-level code, when you are writing applications and you want to compile things, your code needs to be inside of structures like classes or objects. And later on we'll see that it can be inside of traits, but you can't have just this freestanding code out here. So we have to put this inside of something. And in this case, the something I'm going to put it inside of is a companion object. So our class is called vect3. So I'm going to make an object called vect3. Okay. And just by doing that, I'm able to, oops, I need some news in here. I had been playing with this and I had introduced some errors. We haven't written the code that will do that. We'll do that in just a second. Okay, so this compiles, and if you look now, there is a vect3.class and a vect3$.class. However, I can't run this. And if I try just running it, it says there was no main method in here. And indeed, we haven't written a main. Now, we'll come back and we'll write the main. So why do we want to have companion objects? Well, it turns out you've been using companion objects a lot already. And we can demonstrate this by opening up the REPL. And probably the first place that you used a companion object, actually no, technically the first place that we looked at companion objects was things like int.maxValue. Turns out this is making a call to max value on the singleton object int, which is a companion object of the class int. The place that it's more interesting and relevant to us was when we did things like this. And as you are all aware, this creates a new array and gives it the values 1, 2, and 3. But what is this really doing? Well, remember, we just saw in a recent video how there are some special methods inside of classes. And one of them allows you to treat an object like a function. And so we talked about the fact that when you have an object and you put parentheses after it, what's really happening is it's calling the apply method on that object. And all the time that we've been doing array 1, 2, 3 or list 1, 2, 3, or we've been doing this. Turns out array.fill and list.fill are also making calls to the companion objects. So there is an array class, there is a list class, and there is a companion object for them, which has these various methods in it, including an apply method. This is actually a standard idiom in Scala. Instead of making it so that we have to call new to make stuff, you can put inside of there an apply method. And so in our case, I can make an apply method that takes an x, a y, and a z, and it gives back a new vect3 of xyz. And the reason I would do this is that once I've done that, I no longer have to write new on these things. And this actually makes it look a lot more like many of the libraries that you're used to. And you can see why I had that bug earlier. So if we quit out of here, and we go ahead and we compile this, it compiles. However, it still doesn't run because it doesn't have a main. Turns out that's easy enough to fix. Our companion object, just like any other object, can be an entry point to an application. And so I can define an appropriate main inside of here and indent the contents. And now if I recompile it, I can, run the correct name, and there we go. So this runs the same thing that we had from our script earlier. Now, it's worth asking the question, why should you want to have this apply method in here? Why is it better, for example, to have the ability to do that instead of to say, in fact, if let's do a load. Actually, no, I should be able to do this because I'm in this directory. Let's see if this works. Not vector. Not vect3. There we go. Excellent. And so let's call this v.x, v.y, v.z. Note that this only works because I ran the REPL inside of the same directory where I had compiled this. By creating those .class files, I have access to them in the REPL, and I can play around with things. So that's a nice benefit that Scala gives you. So even when you're writing applications, you can bring up the REPL and play around with things. Okay, so I can instantiate this, and I get back a new vect. Of course, that apply method allows me to do this instead. What's the real advantage here? Well, the real advantage to this is actually a little bit more subtle, and it's something that will make sense later on, more so than it might right now. If we do things like an array, we get back an array. If I do it with a list, I get back a list. There's another type that we will learn about in more detail later on, called an index sequence. And it turns out that an array happens to be an index sequence. But when I do this, note that the object I get back is not an index sequence. I get back a vector. We've seen vectors before when we did something like 1 to 10 dot map of underscore times 2. When we mapped on ranges, they gave us back index sequence, and in particular the index sequence was a vector. If you say, when you use the form where you say new, so when I did new vect3, I am guaranteed to get back a vect3. That's the only thing that this can give back. When you say new, whatever type you put here is exactly what you're going to get back. You've lost some flexibility. When you do it this way through an apply method, though, because remember this right here, the index sequence, this is actually short for .apply. When you call the apply method, it can actually change and decide to give you back a slightly different type. And we'll go into the rules of that when we talk about polymorphism in a few chapters. But this is actually a significant increase in the power and the flexibility of your code. If you were working in a language such as Java, where you don't have the ability to do this with the apply method, you wind up creating things called static factory methods and stuff like that. So this is something that happens in a lot of languages. It just so happens that the way it's done in Scala is very smooth and very seamless. In some way, it's seamless enough that you were doing stuff like this a long time ago and didn't really necessarily know the details of what you were doing, but it just worked for you. And so that's one of the nice things about this approach. So that's it for our coverage of object declarations. We looked at the basics of them, we looked at how they can be used as the beginnings of applications, and we looked at how you can create companion objects as well. One other thing that should be noted about companion objects have access to any private data. So if I put something private in the class, the methods down in here would be able to access them. Turns out that if I put something private in the companion object, the class is able to access that private stuff as well. So that's the other advantage of things being companions. So we'll see a lot more companion objects as we go, but that's it for this video. And we'll come back and actually run through an example of building stuff in an object-oriented way and show you how to think more in an object-oriented way in the next video.